So Netflix, they build that recommendation system based on the interest or activity which you do. And they'll also be feeding you with the same data that you're interested in. So that is what machine learning is. So what are the types of machine learning? There are three types of machine learning algorithm, which are the supervised learning, the unsupervised learning, and the reinforcement learning. Because I don't have much time, I'll just be focusing majorly on supervised learning. So what is supervised learning? Now, supervised learning is a technique in which we teach or train a machine using labeled data. So this supervised learning, from the word supervised, means it needs a guide. It needs like the machine needs you to guide it. It needs you to instruct it on what to do. So that's what supervised learning is. Let me give an example. Like as a kid, like I know when we're growing up in school, most of us don't like mathematics. So if you have a common or a complex mathematics problem to solve, so no, no. Okay, I'm sorry, guys. The network here is not really good. So, can you guys hear me?
Yes.
Okay, thank you. So I was talking about supervised learning. I said supervised learning is a technique to teach or train a machine using labeled data. So, what is even a labeled data? A labeled data is the data which has attributes or value attached to it. So I was giving an example, like as children, as when we're growing up. I know most of us don't like mathematics. So if we have a complex math problem to solve, so we either go to our math teacher or we go to someone who can help us solve that problem. So what does that person do? The person teaches us how to solve it or how it is being solved. So that is actually what supervised learning is. From the word supervised, it means giving, like guiding the machine on what to do, instructing it on what to do. So that's what machine learning is all about. And supervised learning is a type of machine learning that involves a guide. So we should note that supervised learning is machine learning, which what involves a guide. So how does supervised learning works? Supervised learning uses a training set to teach models to yield the desired output. Supervised learning, this training data set includes inputs and correct outputs, which allow the model to learn over time. And supervised learning can be classified into two types, which is the classification and the regression. Let me explain the classification. Let me give an example. Now we have we have images of an apple and an orange. Now we have like 5 images of an apple and 5 images of an orange. So we tell the machine that, okay, when you see a red rounded fruit, we label it as an apple. Then when we see an orange rounded fruit, we label that as an orange. So we train this data. With classification is all about categorizing it. So we categorize the apple. Sorry, can you guys hear me?
I can hear you now.
Hello, am I still on?
Yes.
You are on.
Okay. I was talking about how supervised learning works. I said we have 2 categories. We have the classification and the regression. So I was giving an example. I said when we have images, we have an apple and an orange. Now we categorize. Classification is all about categorizing things, putting them in categories. So we train the machine, telling it that, okay, when you see a red rounded fruit, it should be labeled apple. You label it apple. Then a orange rounded fruit, it's an orange, labeled orange. So now we categorize apple into one side and orange another side. So now when categorizing this, we train the data that, okay, this is an apple and this is an orange. Now the machine learns from the experience of what we are doing, from the labeled data that is given. It's training and is learning from those data. So when you now show, when it sees an image which is a red rounded fruit, automatically knows that that is an apple because of the experience it has had while training it. Let me give you a case study. Now, as you have a child who really doesn't know much. Now, a small child, maybe like 2-3 months, or let's say 4 months. Now, you bring an apple, you buy an apple to the house, and you put the apple on the table, and you tell your child, oh, Titi, this is an apple. Now, Titi doesn't know that that is an apple. If Titi goes out, she won't know that that is an apple. Why? Because you have not taught her, you have not trained her to know that that is an apple. So why teaching Titi, when you bring the apple home, you tell her that this is an apple. The next day, you bring another fruit, like maybe orange, you bring it home, and say, okay, Titi, this is an orange. Now, when Titi goes out and she sees a fruit that resembles the one you brought home, automatically she knows that this is the apple Daddy brought the other day. So that is how supervised learning works. So I said, sorry, what do you say?
Share your video, please.
Hello, Samuel, what do you say? Okay. Yeah, so can you see me now?
Yeah.
Okay. So that is how classification works. Numerical labels. For instance, let me give an example. We have a house data that house data has the attributes of things that you should find in a house, like that house data has attributes. Those attributes are things that that forms those house data. For example, we have the price of the house. We have the what type of house is it? A three-bedroom flat? Is it self-contained? So all those things are attributes of the house. So regression is all about numerical data, numerical labels. So, for example, we have a client or an agent, agent A and agent B. Now, agent A wants to buy a house which is situated, which has the price is like 500,000 to 1 million, and it's like a three-bedroom flat. Why the agent and is situated in somewhere like Lekki? Then we have agent who has who wants to buy a house of 150. Then it's situated at somewhere like Ajegunle, and it's a one-room self-contained. Now you trained this machine telling it that a person who buys a house of 500,000 and is situated at Lekki, it's a good house, and it's the house is a very situated house where you can be very comfortable. Then a person who buys a house of 150, then is situated at Ajegunle, that means that person won't have enough comfort at that kind of house. So while training this machine, it learns that someone who buys a house of 500,000 to 1 million, and the house is situated at Lekki, who have is a comfortable house, and person at Ajegunle is not that comfortable. So it learns from this experience. While training it, it learns from the experience. So when another person wants to book a house and books a house at somewhere like Banana Island, it knows that okay, this person is looking for what? Comfort. So that is how supervised learning actually works. So we have some supervised learning algorithms. We have various algorithms and techniques using supervised learning processes. These are some of the most common supervised learning algorithms. We have the naive bars, we have the linear regression, logistic regression, support vector machine, k nearest neighbor, and random forest. So these are some supervised learning algorithms which are supervised learning algorithms or techniques which we use in supervised learning. So some examples of supervised learning are image and object recognition. This is the ability of systems or software to identify objects, people, or places, and actions in images. For instance, for the example I gave the other time of the apple and oranges, so that is an image object recognition. It recognizes that that is an apple. It recognizes that this is an orange. From the image on the screen, you can see that it's recognizing that this is a chair, this is a dog, elephant, and also a car. We have predictive analysis. This analysis is an advanced analysis which is used to make predictions about unknown future events. We have also the spam detection. Spam detection is another example of supervised learning model. Using supervised classification algorithms, organizations can train databases to recognize patterns or anomalies in new data to organize spam or non-spam related. So, so for this spam detection, most of us have emails. So in our emails, we see that there's a filter which filters spam email. What this spam detection does is that when it finds a word, maybe like an offensive word, it categorizes that as a spam email. Then the non-spam email are emails that doesn't contain like offensive words and some other things. So the challenges we face in supervised learning. Okay, supervised learning models can require certain levels of expertise to structure accurately. Training. So what this is saying is that for you to be able to use supervised learning, you must be able to understand some certain models or certain things that should be put, because supervised learning is all about the guide. Like you should know how to guide your computer or your system on how to be able to know and to be able to train. When you are training the data, you should be able to guide this machine, because it can't learn on its own. That's why it needs supervision. So you need to be able to guide this machine on how to learn from the data given to it accurately. Training supervised learning models can be very time intensive. Yeah, supervised learning can take a lot of time. So data sets can have a higher likelihood of human error, resulting in algorithms learning incorrectly. Okay, for this, you have a data set, and this data set, it has some blank spaces in it. So automatically, this machine cannot fill those blank spaces. So indirectly, it's going to bring an error. It's not going to learn accurately because of the spaces that are there. So when giving a machine a data, you should be able to make this data correct. It should be very, very accurate, because if it's not accurate, it will make the machine bring an in it will bring result to an incorrect label or incorrect result. So unlike unsupervised learning models, supervised learning cannot cluster or classify data on its own. Yeah, so unsupervised learning, it doesn't need supervision. You just put an image there. It's going to classify the image for you. It's going to detect the image for you. But unlike supervised learning, it needs guide, it needs supervision, it needs instruction from the user. So that is all for machine learning. So I hope I have enlightened you on the importance of machine, how it works, the types of machine learning, supervised, the challenges faced, and how supervised learning works. So thank you all for listening. Thank you for for attending this KD section. If there are any questions, please.
All right, I have a question, quick one. Can you hear me? I said I have a question. Can anybody hear me?
Yes, we can hear you.
All right. For the unsupervised learning, how much of data can we feed? How much of information should we feed our model for it to be able to detect or tell us exactly what we want? You said that you feed, like, for a child, you give a child an apple today, you give a child orange tomorrow. Are we just going to be giving our data our model just one data, or we'll be giving it, like, how much of data can we feed our model for it to be able to detect what we are showing it correctly, give us an accurate result? How much of data can we feed our model? Hello.
Hello, team. Sorry, I was not, like, my network was shaking. Sorry, what do you say?
Model for it to give us an accurate result.
Okay. Is it okay? Just how much can you feed the data? Okay, you can feed the data as many data you want, depending on the type of algorithm you are using. For supervised learning, I think it can't take a lot, but I think you can feed the data as many data as you want.
All right.
So let me help Victor here. I think unsupervised learning has a reward mechanism. Reward mechanism means the agent moves around, and when he gets a negative reward, he knows that I won't take this path anymore. If I pick this fruit, it will not work for me. Positive rewards are the ones he will continue to go through, like he's training itself. I don't know if you get. In an unsupervised learning, you don't tell the agent what to do. The agent uses its intuition. So how the agent gets to the correct value, or what you want, predicts rightly, is because the agent in milliseconds goes round, like, depending on how many times you say the agent to just route the environment. So doing that, he learns. How does he learn? If he gets to a place, for instance, if he gets a data and this data is not the right one, he gets a reward system like -1. When that happens, the agent officially knows that I can't go through this path anymore, because this path will reduce my lifespan, sort of, or will reduce my reward. So that is how unsupervised learning works. Because I think you asked about unsupervised learning. Most times it doesn't need much data. Unsupervised learning is for the future. That's why it uses its intuition. I don't know if you get.
Which is supervised, unsupervised?
That is for unsupervised learning. Unsupervised learning.
Yes, I understand you. Can I have a model that is supervised and an unsupervised model, whereby the first time I feed it just like one data, then other times I just feed a random data. I should decide, should cluster it. Do you want to cluster it?
Yes, you can have, because that
I
is
have a model that has both supervised and unsupervised.
yes, they have. That is because that is how self-driving cars work.
All right.
They feed them with
Question. Is it possible to treat the learning with a particular information and expect it to evolve itself and to keep itself?
repeat yourself again, because I can't hear you very well.
It's not, your voice is not loud.
It's not loud.
Okay.
Yes.
Is it possible to have a learning whereby you just feed that pot with a single information and you expect it to keep growing itself, determining the type of database it gets from different people? just keep growing itself without you supervising it. Like, you know what I'm saying?
Yes, I get you. It's exactly the same question he asked. He asked if they're in, you can impute supervised learning model and that of unsupervised. The little data you give, you feed your system with, is like you giving it an insight to what to do. That is sort of supervised learning. The other you don't give is telling the agent, okay, this is what you have to do with. But if you don't see anything, if other data are coming in, I don't know what those data would be. Use your intuition here. This is unsupervised learning. The only thing you do is so mathematical. That's why a lot of mathematics is in it. What they do, they have a model of reward system. So while those new data are coming in, the agent routes them on its own. Now you are not the person, you don't determine what the agent does.
Okay.
So if the reward system determines how the agent performs with the new data it's getting.
Oh, all right, I
Yes.
understand. All right, thank you very much, Michael and Cardinal, for the.
Sorry. One last thing.
Hey, Samuel, actually.
One last thing. Can you... Okay, so I can go on with it.
Yeah, you can go on, please.
All right, for the unsupervised learning, it has never been labeled. How does he know the exact name for after clustering? How does he know the name to give that data? You know that it has never been labeled. He does not know the name of any of all those things.
Deep question.
Yes, unsupervised learning has where its use cases. Pure supervised learning is face detection, detecting flowers, detecting fruits. That is supervised learning. Unsupervised learning has to do with its environment. If you say its use case is example is self-driving cars. Another use case of it is predicting stock prices, future stock prices. So it's both of them have different use cases. So if unless that agent is developed sort of to function like a robot, then it can learn on its own. It means that is where neural network would be.
Yeah.
Okay.
That's where artificial intelligence comes.
We know what our neural means, like our brain. Is it? That's where neural network
comes in.
Yes, that's where neural network comes in. So it works right now like a robot. It can now walk on its own, walk around. If it is a hospital, for instance, and it has somehow been programmed to understand that this person with these symptoms is an Ebola patient. Now, the neural network embedded in it allows it to learn future symptoms, like our brain functions. So the use case of supervised and unsupervised learning are different, but nevertheless, both of them can work together. I don't know if you get.
Okay, wait. Is it what you're trying to say? Like, if two bots are created now, one is supervised and one is unsupervised, the supervised one can start working immediately. Why the unsupervised one will have to wait to gather more information before it decides to give results? Is that what you're saying?
Yes.
Okay.
Yes, because if you in trying to develop models like that, they give 20%. It depends on what you want. If the data that have been fed to the machine, you can say, okay, 50%, make 50% of its analytical skills or its intuition. Use it for the data you have. The remaining 50% will be left for data that will come in later, which you the developer don't know about. You don't know what they will look like.
Yeah, that's true.
Do you get? Yes.
Thank you everyone for attending this session. I really appreciate your presence here. So
I have a question though.
hey, brother. Sorry. All right, please come up with your question.
Okay. Is I was going to, it's about when we want to log into sites, then reCAPTCHA comes and asks if you're a robot. Is it that robots are not capable of identifying images, or how does that what's the idea behind that kind of programming?
The idea is just supervised learning. So robots are most times developed to do a certain task. Aside that, they don't do. Aside that, they don't think on their own or for themselves. It's just of recent that neural network is being employed in some robots now because of some certain things they will be doing for future purposes.
Which I didn't get that properly. Are you saying robots can identify those images or they can't?
Those catchers were there as in before this neural network technology being used for robots.
So you are saying right now in this present day,
in this present times, it's possible a robot, yes, can do that. A robot can write programs. A robot can write programs. A robot can drive cars. A robot can do things right now. So a robot,
There's
a robot
already
can
GitHub Copilot. That's what GitHub Copilot does.
Yes. You can now have a robot that is developed and you can control it. If every of these machine learning algorithms and machine learning types is employed developing the robot, you can't control the robot. Because if you tell the robot to learn on its own, it means after learning, you cannot predict what the robot can do. So that is just it. It's just like creating humans that cannot breathe.
But does that not sound dangerous? Like, does it sound very safe?
Is it?
Does it?
When you're not able to predict what a robot can do after you've programmed it to learn on its own, I mean, is it very safe? Like, is it something that you would want to continue? Because honestly,
okay, it depends. It depends because I think most times it's not somehow safe though in terms of its destructive tendencies. But robots learn according to the environment it is in. If a robot comes into a violent environment, it learns violence.
okay.
It learns violence. Probably, if you might have watched some movies where they try to test this kind of unsupervised learning robots.
Terminator and iRobot.
Thank you. If as they've been sent out, the first people they meet, how those people approach them matters a lot. If you see them and begin to shoot at them, it means they will be violent all their life. They will see human beings as enemies. So anytime they jump human beings, they hit.
Good morning.
Good morning.
Yeah. Okay. I'm sorry to disrupt or sorry to interrupt, but it's time for stand up. That's why I just wanted to say.
All right. Yeah. Thank you, Patrick. It's time for stand-ups. I'm trying to talk of the session where people are enjoying this. All right. Please let everyone attend stand-up now. Thank you, Patrick. Thank you, everyone, for attending this.